Hi everybody, welcome back to goal number 1. This is the extension, which is doing I of higher powers. So we're going to talk through how to do higher powers of I, where we have I to the 416th, 519th, and stuff like that. What we're going to find is that we can use our calculator to do some of the complex values, but there are limitations to what the calculator is capable of doing, so we have to actually figure out a way to do these without the calculator. Okay? So here's what we're going to do. We're going to go through first what we can do on the calculator, and I want you guys to recognize a pattern. What we'll find is that we already know that I is just simply I. And we know that I squared is simply equal to a negative 1. We know that from the first part of goal number 1. But when we take I cubed and we try to simplify this, try to apply the fact that we know these two parts are the equivalent of I cubed if we put them together. So what I mean is I cubed is the same as saying I squared times I. Well, we just saw that I squared is the same as negative 1, and I is the same as just I. So if I simplify this, the simplified value would be negative I. Okay? What about I to the 4th? I to the 4th applies the properties that we know up here as well. The simplest way to do this would be to say that I to the 4th is the same as saying I squared times I squared. We just learned that I squared is negative 1, and I squared is negative 1, so that means that this is all going to equal 1. Nice, perfect, round number. It's not negative. It's positive 1. Very easy to work with. Let's check these all on the calculator, though, to make sure that we did do them right. I is actually located down here by the decimal on the calculator. Let me zoom in so you can actually see it. Okay, I is right there. It's a little blue cursive thing, italicized actually. And so when we say to our calculator, tell me the value of I, it just gives us I. Tell me what I squared would be. I squared is going to be negative 1. Let's do I raised to the 3rd, and it's negative I. And I raised to the 4th is equal to just 1. So we have all 4 of those done correctly. I to the 5th power applies the principles that we just saw. I to the 5th power is really I to the 4th times I. And what we just saw is that I to the 4th is 1, so really this is like doing 1 times I, which means that we just have I. I to the 6th is like doing I to the 4th times I to the 2nd. And we know that that's 1 times negative 1, because that's what I squared is equal to, which means that this is negative 1. I to the 7th is like doing I to the 4th times I to the 3rd. So that's like doing 1 times, and I to the 3rd we know is negative I. That means that it's negative I for the simplified value. And then I to the 8th is like doing I to the 4th times I to the 4th. Well, that's like doing 1 times 1, which just equals 1. Now, here's what hopefully we noticed. Oh, and actually, I'm sorry, before we do that, let's check our answers, okay? If we use our calculators to check the values, because we're all so reliant on the calculator, let's see what we can actually do. If I go I to the 5th, I still get an answer of I. If I go I to the 6th, I get an answer of negative 1. But watch what happens when we go I to the 7th. Now our calculator screws up and it has some sort of programming error. What about when I try I to the 8th? Again, doesn't understand exactly what to do, so its answer is all messed up. So how am I supposed to use this if I have to do higher powers? Well, this is where our calculator is no longer really needed, and now we actually just look at a pattern instead. What we should see is that the first time we did it, it's I. The next time we did it, it's negative 1, and then negative I, and then positive 1. The pattern that takes place here is that this will keep repeating itself, and it will repeat over and over and over, and the pattern happens every 4. What do we mean then in terms of how we use this for higher powers? Well, if we took I to the 2nd, or I'm sorry, I to the 12th here, we could break this up and say it's I to the 4th times I to the 4th times I to the 4th. I'm using I to the 4th because we know that this is equal to just a 1. Real easy to work with. So this is like saying 1 times 1 times 1, which simply equals 1. So I to the 12th power is going to equal 1. what about I to the 23rd power? This is like doing I to the 4th times 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 I to the 3rd. Okay? And once we've done this, zoom in here. So this is 20 i's and then 3 extras remaining. Well, I to the 4th we know is 1, so this is 1 times 1 times 1 times 1 times 1 times I to the 3rd. That means that if we simplify this, this is simply going to be I to the 3rd, and we just figured out the pattern that I to the 3rd is equal to negative I. So I to the 23rd power is equal to negative I. So here's the deal. This gets pretty cumbersome to write out I to the 4th over and over and over and over. So how do we do it a little simpler? Well, we know that pattern happens every 4 times. Excuse me, or it resets every 4 times. So let's use that to our advantage. Instead of just doing this, let's divide by 4. So if I had done I to the 12th power up here, and I divided it by 4, I to the 12th divided by 4 would just give me I to the 3rd. And I to the 3rd we know is just negative I. That's not right. I'm sorry. It divides evenly 3 times. And since it divides evenly 3 times, we're left with just I to the 4th 3 separate times. I apologize. I totally just messed that up. I to the 12th divided by 4 is like doing, we just said I to the 4th times I to the 4th times I to the 4th. Okay? So that's a little screwy. Let me get to a different example here that'll make more sense. Okay? I to the 106th. When I do I to the 106th, and I divide it by 4. Okay, what we're going to find is that 106 divided by 4 is equal to 16 divided by 4 is equal to 26.25. I don't know why I said 26.25. It's 26.5. What this means is that I can write out I to the 106th 26 separate times as I to the 4th. But I will have 0.5 remaining. So this is like saying I to the 26 and 2 over 4. The pattern happens every 4 times. So this is the 1 if I had 1 remaining. This is if I had 2 remaining. This is if I had 3 remaining. And this is if I had 4 remaining, or none ultimately at the end. So I to the 26 and 2/4 means that we're going to have just I to the right here would just be 2nd power, which means the simplified value for this is negative 1. Okay? I to the 381st power, do 381 divided by 4, we get 95 and 1/4. That means we'll get I to the 4th 95 times, and then we're going to go 1 time into the new pattern. So remember, the pattern starts over. Here's the first one, I. So because of this, it's just going to be I to the 1st power. Okay. What if we did 416th? I to the 416th power. If we did I to the 416th divided by 4 here, we end up with 104. Since we have no remainders, we end up with an even nut value, which means 4 out of 4. So that means that we have just 1 for the value. Okay. And if we do 519 divided by 4, we end up with 129 and 3/4. Since we have 3 remaining, we go 3 down into the pattern, 1, 2, 3, and that means that this will simply be a negative I. Hope this helps. Sorry for all the mistakes. Watch it again, and hopefully you'll understand it. Take care.